So continuing along the same line but adding a bit more different information, as I mentioned in the last podcast, this is from Peter Dominical's paper on cultural responses to climate change, and it still kind of tries to argue the point about whether there is environmental determinism, or do cultures respond with innovation to environmental or climate perturbations and then decline gradually rather than collapse. So structures emerge from the surrounding tropical forest at the Maya archaeological site of Tikal in Petén, Guatemala, at its peak in the late Classic period of circa 800 AD. This urban center in the southern Maya lowlands supported 60,000 inhabitants, which may not sound like big, but compared to the relative population size, that population density would have been very high. It was largely depopulated after the 9th century AD demographic collapse. So here the word collapse is used, but it's a demographic collapse, which means population would have dropped, but we don't know how gradual that was, as we saw with the example of southern US and northern US before. Okay, there are also evidences of having invented various water structures to manage the relatively dry climate. Remember, the South American, North American west coasts are relatively dry because of the cold La Nina like normal temperatures around Galapagos, which produce drier climate along these coasts. From the same paper, we are looking at some evidence of climate indicators. So sulfur, delta O18, this is from Lake Chincanancanab, Yucatan Peninsula. How do Chichancanab, yeah, that's how it is probably pronounced. Lake Punta in Laguna, and Maya cultural periods shown here, and this is the Calcaya ice core from the Peruvian Andes mountains, looking at particles which are indicators of dryness as well. So you can see that there is the late pre-classic and classic period here, and the post-classic period here, that are shown with this gray band. Mesoamerican paleoclimate and classic Maya collapse. So this is terminology that is not preferred by everybody, as we saw. Incipient collapse of classic Maya civilization began near 750 to 790 AD, which means it was actually not a collapse but a gradual change. Maybe there is a word play there, but nonetheless, the last Maya stela or monument construction has been dated at 909 AD, so it did happen over a century or longer. This is on the basis of Maya long count inscriptions. Well-dated sediment cores from lakes of Chichancanab and Punta Laguna document an abrupt onset of more arid conditions spanning 200 years between 800 and 1000 AD here. So you can see the signatures spiking in sulfur. So if you come this way from 2000 years ago, there is a big increase, and then back as the dryness disappears. Similarly, located in delta O18 in both places. This may not be as distinguished as this place, this spike here, but it is a growth and then a retreat. But there is something similar here, maybe not as long lasting as this one. And the dryness is obviously indicated as particles in the size of the particles matters, because the fine dust can happen even during a wet period during non-rainy seasons, but as the size of the particles increases, you assume that dryness is persisting. Okay, so a century-long dry period coincides with the Maya hiatus centered around near 580 AD, which would be somewhere here, this line. Okay, which documents a period 530 to 650 AD of marked curtailed monument construction. Windborne particle concentrations from annually dated Calcaya ice core in the Peruvian Altiplano is also shown here. So obviously you try to match peaks in different evidences from different locations, and you try to match it with historic records. So in what context can we say a collapse when the civilization went over many centuries? So demographic collapse, on the other hand, is a different terminology, where you can say the population probably went, let's say, from the levels of 60,000 to half or 25% or whatever of the peak. Okay, let's take a few more points from this edited book called Climate Change and Cultural Dynamics, which are kind of related. So we are again looking at the various periods of the Holocene. Pollen profile from Lago Anari in east central Marajo, showing fluctuations in the extent of forest during the past 7,000 years. The C14 and TL dates for replacements of the archaeological phases correlate with declines in forest vegetation circa 2800 to 2000, 1500 and 700 calendar years before present. Basically still confirming climate variability, but from a different site. So it's showing ecotone changes, so going from trees to other herbs and graminae over different periods, and you have on this side depths in meter below the lake bottom. So it just shows you percentages and timelines as measured by depths here, going in meters. Okay, so different periods are recognized, and calibrated dates are shown. So the postulated distribution of rainforest with a reduction of 40% in annual rainfall based on the present day isoheights and correlation of savanna and savanna woodland vegetation with rainfall below 1500 millimeters. That's a lot of rain. So that's the greening of Sahara there that we've talked about. A large refugium would have existed in the northwest, and smaller refugia in central and eastern Amazonia. So somewhere here a refugia and central eastern region, based on the typography of refugia formations. Okay, so here we are looking at rainforest, somewhat drier rainforest in lighter shadings, savanna, cerrado, and dry deciduous or savanna forests when the shading gets further lighter. Savanna, cerrado, and locally semi-desert with these light gray colors, and dune fields shown with these triangular symbols here. Okay, so you can see the gradations of vegetations, and obviously that would have had impacts on agriculture, culture, dependence on mixes of food for survival. Okay, so this shows that in terms of locations of rock shelters and isolated projectile points in relation to the distribution of forest vegetation during the late Pleistocene, so talking again about 12,000 year timeline, assuming a 25% reduction in precipitation and similar distribution, so some sensitivity assumptions made, and these are the different locations, and I won't go into the details, but you can see the detailed catchment hydrology of Amazonia. So fluted, unfluted, contracting stem, and rock shelters are all shown. Now you can try to map those onto the vegetation types to see how hunting and gathering would have complemented other agricultural related activities as well. Okay, so this is more about cultural responses and dynamics. Percent of subsistence remains contributed by wild animals, wild plants, and cultigens, and domesticated animals over time in Tehuacan Valley sites. So we are still in that area. We are looking here from time going from the beginning of the Holocene 10,000 years ago, but you can see that the C14 calibrated years are slightly different. Even though they are same here, you can see immediately they begin to differ from each other by various amounts. C14, as you remember, is formed by cosmic rays bombarding nitrogen, and it's radioactive, and once it's put into the sediment or taken up into photosynthesis, it begins to decay. So its depletion relative to the standard will tell you how old things are from where you got the C14. So wild animals, a lot more in their fraction here and decreasing over time and different size. Wild plants, a lot more here, maybe peaked somewhere in the middle Holocene and then tapered off, whereas cultigens, which were basically absent during the beginning of the Holocene, have grown over time to 500 years before present. And domesticated animals in this site didn't appear till about the middle Holocene, 5,800 calendar years, and have increased somewhat to 500 calendar years before present. So you can see how the mix of dependence on hunting, gathering, and agriculture and domesticated animals changed in terms of cultures over this time. Looking now in Africa, Holocene lake levels in Chad. So again, we have seen the 8200 year event happening somewhere here. Not so well seen in Chad, but seen at higher latitudes. But you clearly see the wet and dry periods. So you had the bumper monsoon time. Remember, Chad is in the western region of Africa, so away from the Nile. So any wetting here would have resulted in civilizations establishing themselves in what is now a very dry region. Okay, Chad has now been impacted greatly by human activities as well, in addition to climate. So then there is a steep drop when the cooling is also seen over parts of Europe and over parts of India, the 4200 year event there, and then these little oscillations going all the way into the recent times of the Holocene. Looking at a similar figure as before, we are looking at climate, so calendar years before present going now to almost the end of the last glacial maximum, looking at very dry regions coming out of the glacial, progressively getting wetter and getting very wet during the pre-Ubaid hunter-gatherer and early agricultural period at the beginning of the Holocene, and then somewhat of a drying but slow wetting as well over Ubaid, Uruk period, Sumerian civilization, and the dynastic periods. Okay, so these are the cultural periods. These are the Dolomite proxies for wet and dry southwest monsoon evidences. And continental climate in the Red Sea region also went from arid transitioning to humid, back to arid, most humid period here in this region, humid transition towards arid regions. And of course, there has been solar radiation forcing, which never goes away, because you have orbital changes, ellipticity, precession, and obliquity happening continuously at 20,000, around 21,000 years for precession, 41,000 for obliquity, and 100,000 years for ellipticity. But ellipticity and precession combine to produce a dominant forcing at approximately the precession timescales as well. So you can see how the radiation in the northern hemisphere changed in the summertime and in the wintertime. These are the positive numbers and these are the negative numbers here. So all these would have caused summers to be warmer, winters to be colder in Arabia and southern Mesopotamia, Mesopotamia, with seasonal differences and inferred strength of summer monsoons peaking at 9 to 10,000 years before present. Note the relations with humid arid cycles in the Red Sea region, representing a synthesis of changes in lake levels, vegetation history, and sediment data. So these are the kind of details we have to keep going through, and maybe I will leave the ENSO threshold to the next podcast, because ENSO, which is a dominant mode of natural variability even now, has a key role, because we also want to understand how ENSO will change in the future with global warming. We don't have a very solid clue about that, because some say ENSO will get stronger and more frequent, some studies say they will get weaker, and so on and so forth. And even the basic warming pattern, especially in the Pacific, has to be understood in terms of how the coupled climate system is responding to global warming, and how the background state changes then affect El Nino, which acts at multi-year time scale on the background state. So we'll come back and look more specifically at some ENSO variability through the Holocene, because that very closely relates to year-to-year changes in temperature, precipitation, humidity, impacts on crops, health, and so on. And there is evidence that El Niños in the modern times now have impact on civil conflicts because of these environmental impacts and resource limitations, especially water and food. Okay, so we'll do that in the next podcast.